Hello, good day. Basically, we're going to continue from where we stopped in logarithm. I've given the definitions, written the laws and their proofs. So in this class, we're going to look at their basic operations. So we're going to look at how do we apply these laws if questions arise from logarithm. So we're going to look at that in this class. So basic operation. Of logarithm. Okay, so we're going to look at the law. First, I define logarithm. I specify the laws and their proofs. So we're going to basically start with all of them. We start from the definition and the law one by one so that we can see how they operate. So those are the things we're going to do in this video. Very quickly, example one. Example one. Evaluate log 1000. So this is what they asked us to find. So look at solution. We're looking at log 1000. If you recall, in the definition of logarithm, I said in most cases logarithm are expressed in base 10, and if they are expressed in base 10, sometimes the base will be shown. But if the base is not shown, you know that that logarithm is what? To base 10. So this is what they asked us to do. First, from definition of logarithm, we say that the logarithm of any number is the power to which the base is raised to give the number. So we are going to ask ourselves, how many times are we going to raise the base? So we know the base here is now 10. How many times are we going to raise 10 to give 1000? Which is 10 times 10 times 10 first. 10 times 10 is 100, 100 times 10 is 1000. So it means this is 10 raised by what? 3. So it means we are going to raise 10 into 3 places. 10 raised by 3 will give us 1000. So the logarithm of 1000 is now what? It's now 3. Log 1000 is what? 3, because the base is 10. So if we do that, we can say this is log 10 raised by what? 3. And we know from this law that if we have x base b, n is equal to n log x b. So here, this 3 will come here and this become 3 log what? 10. You know log 10 here, log 10 here is 1, because since the base is not shown, I told you it's base 10. So this one simply means 3 times what? 1, and the answer is what? 3. So that is how we operate. So this is, I have just given this example based on the definition to know how the laws operate. We're going to move fast. Okay, that's the first one here. Then assuming we have let's look at another example. Example 2. Evaluate log 8 to base 1/16. So we should evaluate this. So if you look at this, you see the base now. We're going to ask ourselves, how many times are we going to raise 1/16 to obtain 8? That which I cannot state. But in this case, what you do, you say, suppose. We can say suppose, or let we assume that log 8 to base 1/16 is equals to u. I see let it be u. So recall, because we want to try and formulate that this is it, the whole of this is this. But then, if you recall when we're trying to look at the proofs of logarithm, I said sometimes you look at the base here for you to formulate this the right hand side. So here we can simply say that this is log 8 1 over 16 times is equals to 1 times u. This one here, since the base is 1 over 16, we can say now that this is log 1 over 16 to base 16. You know, the whole of this one is equivalent to what? 1. So we're going to replace it. We do need the cos. The base here is 1 over 16. That's why we formulate it. That's how we roll. Okay. Now we can now move forward and say that this is log 8 1 over 16 is equals to log 1 over 16 to base 1 over 16. Because of that, this u we are having here will now be raised to power what? This 1 over 16 or raised to power what? U. That's how we normally do it. That's how it goes. Okay. Now what we need to do, we say equate base. Or no, we equate log. Yeah, we equate what? Log. By equating log, equate what? Log. So by equating log simply means that this one will simply what? Go with this. And we will be left with 8 is equals to 1 over 16 all raised to power what? U. So recall, in this 8, you see that they have a common prime factor. A common what? Prime factor. So we express them as their prime factor. So 8 here simply means 2 times 2 times 2, which simply means 2 raised to power 3. And this 16 we are seeing here is 16 is 2 times 2 times 2 times 2, which is 2 raised to power 4. Okay, but if you recall, in our indices, if we have a raised to power minus n, it simply means 1 over what? A raised to power n. So it means that this is the same thing as this. So 1 over 16, this 1 over 16 here, we can also say it is what? 16 raised to power minus 1. That's what I'm trying to draw your attention to. Okay. Okay, if that is true, then we will replace this with this. And you know, since we have said this 16 is 2 raised to power 4, we can replace everything here. 1 over 16. 1 over 16 now, it can now become 2 raised to power 4. This one is minus 4 here. So this minus here, we multiply it. If you recall that in our indices, we say if we have let's say x raised to power n or bracket a, it also means s raised to power what? N a or a n. So this new power will multiply the one that was there before. So here we replace this. This becomes 2 raised to power 3 is equals to 2 raised to power minus what? 4. And we have u there times u. 2 raised to power 3 is equals to 2 raised to power minus what? 4. While they express them as the factor of their prime. Okay. Now what we need to do here, we can as well say equate what? Equate powers. So by equating powers, this, if we have 2 raised to power 3 is equals to 2 raised to power minus 4u. So this will go with this. And 3 is equals to minus 4u. Minus 4u. So our u, if we divide both sides, we say divide both sides by minus 4. Or you say multiply both sides by the reciprocal of minus 4. And this will give us minus 3 over 4 is equals to minus 4u divided by minus 4. So that your u is equals to minus 3 over 4. So it means that we are going to raise we're going to raise minus 1 over minus 16 over 1 over 16 into minus 3 over 4 times before we can get can obtain 8. That's what it means. So the number of times that we will raise this base now, which is 1 over 16, before we can obtain 8 is minus 3 over 4, which is the same thing as minus 0.75 times before we can obtain this. So we can say therefore log 1 over log 8 to base 1 over 16 is equal to minus 3 over 4. This is how we rule here. Okay. Now let's look at another example before we proceed. Like I said, we need to run fast here. So here, let's look at this example 3. Example 3. Given that log base 3a is equals to 1. Find I a and I log log a square base a square of a square base 1 over 3. So we should do this. Okay, now we will attend to them. First of all, we have to know what is A. So we cannot say that this is log A base 3 here. This one here, because this one is base 3, we cannot express this one as log 3. The one here we say raised to power 1. So anytime you see the log here, you just express this in this nation so that you can easily manipulate. So here with the log, I will now know that A is equal to 3 raised to power 1. 3 raised to power 1 is what? Is 3. So we say our first question here, A is equal to 3. We have obtained that. And if you look at question 2, they say we should find, question 2 say we should find log A square to base 1 over 3. So first of all, let's look for A square. A square means 3 square, and that will give us what? 9. So what we're asked to find is log 9 base 1 over 3. So we're going to look at how many times are we going to raise 1 over 3 to give us 9. So in that case, we don't know. We cannot easily know it. So we can just say now let log 9 to base 1 over 3 is equal to V. Let's use V this time. Okay. Alright. So in that case, we cannot say that this is log 9 1 over 3 is equal to log 1 over 3 to base what? 1 over 3. So this one will automatically carry this as power, so that you now equate the log of both sides. So here we now have 9 is equal to 1 over 3 raised to power what? Raised to power V. So you express this as a power, as a prime factors. In its power. So this 9 becomes 3 times 3, which is what? 3 square. And this 1 over 3 here, if you look, as we can express this as a negative indices, which is this 1 over 3 becomes 3 raised to power minus 1. So, and we will replace it here. Here will now be 3. Please let me come this way. This will now be 3 raised to power 2, and this becomes 3 raised to power minus 1. Bracket v. So 3 square is equals to 3 raised to power minus 1 times v equals minus v. Then next you equate what? You equate powers. So that if you equate powers, you will go so that v2 is equals to minus v, and your v become minus 2. So v is now minus 2. So the number of times you are going to raise 1 over 3 to give you 9 is what? Is minus 2. That is just a simple explanation there. Okay, let's look at further example. Now we're going to look at those examples very fast. Imagine that's example 3, example 4. Evaluate or simplify log 2 raised to power 16, okay, log 2 raised to power 32 plus log 2 raised to power okay, let me say here is 16 raised to power this one here log 4 raised log 16 base 2 plus log 4 base 2. So simplify this. Then this now comes to the operation laws. The first law, we say that if the base of a logarithm are the same and you're having a multiplication sign here, what you do, you take them as 1. So this becomes log base 2 here, because there is a addition sign here, will now become 16 times 4. So 16 times 4 will give us 64. So everything here becomes log 2 64. So this 64, how many times are we going to multiply 2? 2 will multiply itself to give us 64. And it's quickly, if we do that, it's going to be 2 raised to power 6. 2 raised to power 6 is what? 64. So here we can say this is log 2 raised to power 6, and eventually this is, we come back here, this is 6 log 2. You know log 2 is 1. So it become 6 times what? 1, and it's what? 6. So you can say in conclusion that log 2 16 plus log follows 4 2 is equals to 6. That is the first law. Then quickly another example. Example 5. Evaluate log 27 base 3 minus log 9 base 3. So we should evaluate this. I'm just looking at this, the basic effects. I'll go into technical one later. Okay. So in this case, this is division sign. You must know whether the bases are the same. If they are the same and there's a division sign here, what you need to do, you have to apply a log. This is log 3 bracket 27 divided by 9. And 27 divided by 9 is 3. So here we have log 3, and our answer becomes what? Becomes 1. See, therefore, log 27 base 3 minus log 9 base 3 is equals to what? Equals to 1. So these are some of the basic operations of the logs. Okay, now let's look at this. Okay, let's look at this. Example 5. Evaluate. Log 5 25 minus cube root of 125. Okay, let's look at this. Evaluate log, let's say 2 raised to power log of 32 raised to power 1 over 5 in base 2. You are asked to do this, like I said the other time, that if you have a log of this nature, your answer is just everything here. So, but everything here is something, so we cannot say that let 2 raised to power log 32 raised to power 1 over 5 is equals to, let it be v. So we take log of both sides to base 2. Take log of both sides to base what? Base 2. So because of the power here, so we have here log 2 log base 2 32 raised to power 1 over 5 is equals to log 2v. So you see this log 2 is off, so we are left with log 32 raised to power 1 over 5 base 2, and here we have log v base 2. So this one, this log 2 and log 2, they are off, and we are left with 32 here raised to power 1 over 5 is equals to v. So here we are now faced with indices. So the fifth root, this one means the fifth root of 32. So which number will multiply itself 5 times to give us 32? So the answer is what? V is 2. It is 2 that will do that. 2 multiply itself 5 times will give you 32. So you now conclude that therefore 2 log 2 log base 2 1 over 5 is equals to what? Is equals to 2. So we end this class here. We come up with more of the laws gradually, so that you have more time, to wash and acquaint yourself with this basic principle. Please do help me to subscribe to my YouTube channel. I'll have more of this video on so many other topics that will soon be uploaded on my YouTube channel. So please do subscribe, and also you can also click on the notification bell so that anytime my video comes up, you can easily get them. So take care, have a nice time.